Okay, today we're going to be talking about machines. We're going to be simplifying them into 6 main types of what we call simple machines. So one of the simple machines is a lever. So this is going to be if you're trying to lift up something that's really heavy, what you end up doing is putting a long piece of wood underneath it and lift it up. So this could be like a shovel. You're going to be shoveling a lot of heavy dirt, and rather than just picking the dirt up like this, you use a lever and you put weight on the end of the shovel handle, and then you'll be able to pick up this pile of dirt. Or in a case of a seesaw or something like this. Another type of simple machine is just an inclined plane. It takes a lot less effort for us to move something up an inclined plane than it would be to just lift it vertically. So an inclined plane would be. Another one would be wheels, and what you can see here is if I want to lift a large box or a large object, I can pull over here, and using the use of wheels, I can be able to do some work on that. And that would be a different type of machine. Another type is a wedge. So if you can kind of picture trying to cut a piece of wood, you're going to put like a little piece in there, and if I put down a force right here, I'm going to be able to split that into 2. And so that's another type of a simple machine. The next one is a screw. And so for us, if I turn this around like this, I can actually do work in creating the force right here. Okay, and then the last one we have is use of pulleys, and very different than the wheels, the pulleys have a set of intricate details here that if I pull over here, I can actually move this larger box with a less of a force over here. So really the whole object of what simple machines are is to change the direction or the magnitude of the input force. So the input force is the amount of force that you're applying. So here you're going to be pushing down on this lever, and you're going to be able to increase the amount of output force with the amount of input force. Here you're changing the direction. Your force is going here, pushing it up here, but your displacement is going to be this way. And all of these here, you're going to have a force that's going to be turning it, and this is what your output force is going to be going down using the screw. And over here, you have a force that's going to be going outside by splitting the wood, and you're going to be putting the force that way. So really, the whole essence of these simple machines is to change the direction or the magnitude of the input force. Okay, so, well, the whole main purpose really to use machines is to make life easier for us. And so mechanical machines give us what we call a mechanical advantage, meaning if I'm going to be pushing something up a large hill with the same amount of force, I want to be able to push with less amount of force to achieve the same amount of output. So what we have is we have what's called a mechanical advantage, and this is not ME, mistake there. We have mechanical advantage, MA, and it's the output force over the input force. So if I put in 100 newtons worth of force, but I get 200 newtons worth of force out, then I have a mechanical advantage of 2. So meaning that it's 2 times the output over the input. So here, if I'm pushing down here with 100 newtons, but it allows me to lift 200 newtons. Normally, I couldn't lift 200 newtons if I only try to lift it with 100 newtons. It's not enough. But using this mechanical advantage, I can say that my output force is 200 newtons. My input force is 100 newtons. Therefore, I have a mechanical advantage of 2. So we have a mechanical advantage. Then we have what we call an ideal mechanical advantage. And the ideal mechanical advantage, the IMA, is the displacement of the output over the displacement of the input. So the displacement of the input force is going to be, when I push this down, it's going to go down by this much distance. And if this was over here and I push it down, this is going to go up by this distance. So this is going to be the displacement output is going to be over here, and this is going to be the displacement input. So the IMA, the ideal mechanical advantage, is going to be taking displacement over output over displacement input, which is different than the mechanical advantage, which is dealing with the forces. So this is the force, this is the displacement. Okay, so now we're going to go into what's called efficiency and how efficient an engine, or excuse me, a machine is, how efficient it is. Well, machine, it measures how well a machine works. So we really want the machine to work at 100% efficiency, which would mean that the work that you get out of a machine has to equal what you put in. But in real life, that doesn't happen. So no machine can ever be perfect. And there's always going to be friction or some sort of energy loss within the machine. So really, if you want 100% efficiency, 100% efficiency is equal to an efficiency of 1, which means that the output work that you get out is equal to whatever you put in. And that doesn't happen. Okay, so we can never have an efficiency of 1. It's always going to be less than 1, 0.9, 0.8. So we can say that we have a car engine is 90% efficient. So the work that you put into the engine, the output is going to be 0.9% times that, or 0.9 times it. Okay, so the efficiency is the work out over the work in. We can also use the equation that it's the mechanical advantage over the ideal mechanical advantage. So we can figure out both of these. Okay, so let's try an example using this information here. A person lifts a 950 Newton box by pushing it up an incline. So we're going to be using a simple machine of an incline. Okay, we push the box up the incline. The box has a 950 Newton box. By pushing it up, the person is exerting a force of 350 newtons. So this force right here is 350 newtons. Along the incline, what's the mechanical advantage? Well, the mechanical advantage, the input force is 350. So this person has to exert 350 newtons of force to get what out? Well, to be able to get 950 Newton forces out. So if you just divide the things together, we have a 2.7 mechanical advantage. So this incline was able to give us a 2.7, that's a 7, 2.7 advantage. Okay, so the lesson is very short today. Don't forget to do the assignment. That's assignment 8 on your Edline account, and we'll see you tomorrow.